Good morning, everyone. Today, let us see the new topic nonparametric methods. Before going to nonparametric methods, let us see the difference between parametric methods and as well as nonparametric methods. First example for parametric methods is developing a model from the training data set. So, when we have a training data set, we develop a model by using any of the algorithm. And to test the new value, we apply the model and we get the answer. That is, a model is generated from the training data set. That is the best example for parametric methods. So let us take one more example. That is, let us assume the distribution of the height of adult persons. This also I have given for the previous topic as an example in the previous topics. So this is the height of the adults. So when we map onto the normal distribution, that is, how do you map in the normal distribution? This axis is the height and this axis may be the number of persons or the probability. Or to find the probability, that is 4.5, how many times it is repeated? It is repeated twice. So 2 divided by total number of values in my data set, maybe 11 I think so. 2 divided by 11, that is the probability of 4.5 that appears in the distribution of height of the adult persons. So 5.5, I think it is also repeated twice. 2 divided by 11, that is the probability for the height of the adult person for height 5.5. So or what we map is, so here suppose 4.5, how many times it is repeated? Twice. So we see here, twice it is repeated, so we mark here. Number of persons, it is 2 persons, it is repeated in my data set. Like this we go on mapping. And we get to this curve, and with this curve we call it as a normal distribution. Why we call it as a normal distribution? This is normal happens in the height of the adults. Usually the average value of the height of the adults is 5.5. It is a peak value, it appears. Maximum number of persons with 5.5 persons appears. So it goes on increasing. Why? Because number of adults with 3 may be few. As we go near to 5.5, goes on increasing. With 4 number of adults with height 4 will be increasing. Number of adults with 5 goes on increasing. Number of adults with 5.5 may be highest. But as we go towards 8, 9, it goes on decreasing. So we get a normal distribution. Always in the examples, we take a normal distribution as an example. Why? Because it is a normal phenomena which happens in the human life. So normal distribution is usually taken as an example. So from this normal distribution, or what we call it also as Gaussian distribution, we get the two parameters, that is the mu and the delta. Mu is the mean of these values and delta is the standard deviation, or what we call it as a variance. So here we get these two values from this normal distribution. So now, so this is the data set values what we know and what is the probability we can get. But for new height 4.0, suppose 4.0 is not present in the data set. I want to find the new, what is the answer for the probability of height 4.0. So what we can do is, we can just use these two parameters, mu and variance, and calculate what is the probability of the height 4.0 that actually appears in the distribution of the height of the adult persons. So how we can find? We can use Gaussian distribution formula. How to use a Gaussian distribution formula? It is 1 divided by square root of 2 pi delta e to the power of minus x minus mu whole square divided by 2 delta square. So this mu and the variance values you can use, and when you can use mu and the that is mean and the variance value what you have got from this data set, you can use and find the x value will be 4.0. That is, what is the value for new value 4.0, x you can use 4.0 and get the answer. That is a probability of the new value 4.0, that is height 4.0 that appears in the data set. So in parametric methods, we require to know only the parameters mu and delta. No need of data set to calculate the probability of any given new data point. So for any given new data point, are required to know only the parameters mu and the delta. No need to have the data set. Once we find the parameters, with the parameters we can find the probability of the new data point. So if this is a data set, you calculate only the parameters. With these parameters, I can find the probability for the new data point. I don't need this data set. I just developed a model. For a new data point, I will apply the model. So no need to store the data set in the memory. That is the main advantage of parametric methods. So from the data set, we will be generating a model. Any new data point answer we want, I directly refer the parameters. With the parameters, I will get the answer. So no need to store the data set in the memory. That is parametric methods. Let us see non-parametric methods. So we are not generating the model from the non-parametric methods. What we are doing is, we are having a data set. For example, with these values it belongs to class A. With these features it belongs to dog. If these features it belongs to cat. If these features it belongs to elephant. These are the features and this is the class it belongs. Now I am having the feature, a new data point value. I have to know to which class it belongs. Whether it belongs to class cat or dog or elephant, I don't know. So what we have to do is, you have to have a data set. You go on mapping the instances with this data set. All these instances of the new data point, you map to these instances, whether it is nearer to this, or it is nearer to this, or it is nearer to this, or it is nearer to this. Suppose if these instances are near to this, I'll say classify as it is a class A. Means I require a data set for any new data points or a new data value. I have to guess to which class it belongs. I have to require the whole data set. So we call it as a local method, but parametric methods we call it as a global method. It should be kept in the memory. Means the data set what we require should be kept in the memory. It will check the nearest data point from the data set to classify the new data point. To classify the new data point, I have to go on comparing with all the instances of the data set. So the memory is required in case of non-parametric methods, but in case of non-parametric methods, but in case of parametric methods, memory is not required. So just I will calculate the parameters. That is, a model is generated. What we can say in the last class, as I was telling, no, model we generate. We generating a model which is nothing but the parameters of the data set. For this example, what parameters we have calculated? Mu and the standard deviation. So we have, from the data set we got the mu and the standard deviation values, and once we know mu and standard deviation value, what is x value, the new height probability we have to find? 4.0. That 4.0 substitute all the values. I will get the answer. What is the probability of the height? 4.0 for the height of the adult persons. So that is the difference between parametric methods and the non-parametric methods. Thank you.